All right, everybody, today we're talking about geometric sequences. All right, geometric sequences. We've got two different formulas here. We've got a recursive formula. A sub n is equal to my ratio times my previous term. Now, this can only find the next term. Here, my recursive formula can only find my next term. My explicit formula looks like this. A sub n is equal to my first term times my ratio to the n minus 1 power. And I can find any term using this. So we're going to talk about how you find ratios. We've got two different examples, and we're going to find the recursive and the explicit formula for both of them. All right, so here is my first example. Example 1. We've got -7, 49, -3, 43. Now, R stands for ratio, and it's super important. I should have written this down. All right, our common ratio. You find the ratio by dividing your second term divided by your first term. That's the first thing that we're going to do here. For example 1, to find our ratio, we take our second term, 49, divided by -7. You can take your calculator and you can divide this, but it equals -7. So to write a recursive rule here, I'm going to write that in pink. A sub n is equal to -7 times my previous term. Or I could write an explicit rule. A sub n is equal to my first term, -7, times my ratio, which is also -7, to the n minus 1 power. Now, let's just say for funsies, let's find the next term here. I'm trying to find this term. So what is that going to be? My fourth term. A sub 4. Here, all I would do is I would take my calculator and I would literally type in -343 times -7. And I would get 2401. So 2,401. But say, for instance, I don't want to find the fourth term. I want to find the 8th term. This is when we use our calculators for this. We're going to go into y equals, and if we have anything in y equals, we're going to clear it out. And I'm going to type in, I'm going to type in this green equation that I have in right here. -7 times -7 in parentheses. You use this little caret button that's right here below your clear sign to the x minus 1 power. I go to the table, second graph, and I'm finding the 8th term, meaning I go all the way down here to find the 8th term. Now, here, if you look just on the table, and y'all can't really see that very clearly, it doesn't give me the full number. So you have to move your cursor over to know exactly the full number right there. So my full number is 5764801, meaning I put my commas where they go. 5,764,801 is my 8th term, which means it gets really, really big, really fast, right? So let's get another example that gets really, really small, really fast. So example number 2. My second example, 12,000, 4,000, 1,333.3 repeating. So same thing, let's find our ratio, our R. It's my second term, 4,000 divided by my first term. And you can also do this in your calculator too if you really are bad at fractions. So second quit takes us back to the screen. 4,000 divided by 12,000. It's going to give you a decimal. If you hit math enter, it changes it back to a fraction and it simplifies it, meaning 1/3 is my ratio. So here, I know that I'm decreasing, which some of y'all might get confused that it's dividing, but instead of dividing, I'm multiplying by 1/3. Multiplying by 1/3. So let's find the explicit rule for, the recursive rule for this. A sub n is equal to my ratio, 1/3 times my previous term. Now, let's just say for funsies, let's find the next term. So I would take, well, and you could do this. You could take, I would take my explicit rule for that. Let's use that. A sub n is equal to my first term, 12,000 times 1/3 to the x, or excuse me, n, missing from not x, minus 1 power. Now we type in an x in our calculator because our calculator only knows x's. So going back to y equals, typing in 12,000, parentheses, 1 divided by 3, our little caret button, meaning our exponent. Remember that caret button's right here. Don't ask me why it's a caret. That's just what it's called. X minus 1 power. Go to your table, and if you notice, it has that repeating decimal, which means that my fourth term is going to be 444.4 repeating. So if I wanted to find my eighth term, a sub 8, it's 5, and then we can round 5.49, just about, if we round it to the nearest hundredth.